In this we want to talk about exponential equations, writing the equations as well as maybe a little introduction to solving them, but we're going to talk about logs in the next few days and we'll get to that then. The population of a big city is 250,000. The U.S. Census has approximated the growth of the city at 3.55% per year. City planners are curious about some population benchmarks that would mean major change in the infrastructure. What will the population be in 10 years? Well, I'm really in this going to focus on writing the equation. I'm going to rely on the fact that you can type it in. So we may not actually be calculating answers, but let's start with the setup. So population's 250,000. That's our start off. So we're going to have 250,000 multiplied by something. Okay? Now, it's growing at 3.55% per year. So right away I'm going to write that as a decimal instead of a percent. Now since it's growth, that means we're going to do 1 plus 0.0355. Okay, let me just write that in there right here. We're going to have 1 plus 0.0355. And that will be the base of our exponential equation. So it's going to be 1.0355. And since it's 10 years, we're going to raise it to the 10th power. Please note that only 1.0355 is being raised to the 10th. We're not multiplying these two numbers together and then taking it to the 10th. The exponential part is just the 1.0355. So we just raise that to the 10th and then multiply by 250,000. If you type in your calculator exactly this way, it will work. The one other thing I want to mention is this works this way because it is a growth equation. Okay, it's growth. If it were decreasing, we would simply change this plus to a minus. It would be 1 minus 0.0355. So it would be something like 0.9645 would be the base of our exponential equation. Okay. Next, at the current rate, how long will it take the population to double? Well, we can set this up, 250,000 multiplied by 1.0355 to the x power equals 500,000. And then we could divide both sides by 250,000 and we're going to end up with the 1.0355 to the x equals 2. Well, I just want to point out that really you could have skipped right to this point. If you had just said, well, I know I'm doubling, so this right here, the base to the x has to be 2, because I'm not changing the starting value. I just know that I have to be multiplying this by 2. This has to be 2, so you could have skipped right to here. Now, as I said, we're not going to spend a lot of time on the solving, but let me just remind you that we could solve this by saying x is equal to the natural log of 2 divided by the natural log of 1.0355. Now, as I said, we're going to talk more about logs in the next couple days, but I know some people wonder, well, why use natural log? Why not log? Important to know that as long as the base is the same on the top and bottom, and of course natural log is base e, as long as I use the same base, I'll get the same answer. So if I had said log of 2 over log of 1.0355, I would get the same thing. Finally, at the current rate of growth, how long will it take the population to reach 1 million? Well, let's use kind of a similar idea we had up here, where instead of actually writing the whole thing down, let's skip to the end. In this case, of course, we're going to have 1.0355 to the x, and we're just going to set this equal to 4, since if we reach 1 million, we're multiplying by 4. So then to solve it, we could use logs again. Natural log of 4 over the natural log of 1.0355. And again, we'll talk more about logs in the coming days, so if you don't quite remember the setup of that, don't worry too much about it. The half-life of a certain radioactive substance is 20 days. There are 5 grams at present. How long will it take it until there's only 1 gram remaining? Well, in the previous problem, we were multiplying by 1.0355. Here, we're multiplying by 1/2, because we're trying to figure out how many times we cut it in half before we get to 1 gram. So we're going to have 1/2 to something, some power. For a lot of people, figuring that power out is a bit of a challenge. It's x over 20, but a lot of people wonder, why isn't it 20 over x? Why isn't it 20 minus x? Why isn't it 20x? And let me just try and explain real quick. We need to multiply by 1/2 every 20 days. So after 20 days, I need to multiply by 1/2 one time. After 40 days, I need to multiply by 1/2 twice. After 60 days, I need to multiply by 1/2 3 times. And that's kind of the way I construct this, is I start to think, well, why isn't it 20 over x, 20 minus x? Well, because I need a situation where when I plug in 20, I get 1/2 to the first power. When I plug in 40, I get 1/2 squared. When I plug in 60, I get 1/2 cubed. This is the only one of those things I mentioned that will work. So now we do 5 multiplied by that. We'll set that equal to 1. Doing a little bit of algebra. Divide both sides by 5. Then we're going to use logs to solve it. So I have the natural log of 1/5 by the natural log of 1/2. Now in the previous slide that was always just equal to x. Of course here it'll be equal to x over 20. So to solve for x, we'll simply multiply both sides by 20. And there's our answer.